Hi, everyone. Thanks for joining me today. I'll be covering Checkpoint's IoT Protect technology and how to integrate and install it in your network easily and seamlessly. So before I jump in, a brief intro on myself, and I'll just share some contact information if there are any questions. I've been in the ICS and IT space, security space for about 20 years, and I've had a lot of experience with OT technologies, medical device technology, and certainly IoT as well. So today's session is going to cover what you can do as an organization to be able to automatically identify, classify, and analyze devices from a security standpoint. The system also allows you to create distinct policies for IoT based on their attributes. So you can have different policies for security cameras versus telephones and laptops, et cetera. It also allows you to identify and block threats via the Checkpoint threat prevention engines. And we will show you how to implement that in a way that allows you to both classify and discover devices and secure them with dynamic policies in real time, something we also do for cloud environments as well. But today we'll be covering the IoT technology specifically. So what does Checkpoint deem as IoT cybersecurity? What we are looking to do is achieve goals in these pillars in order to secure assets and protect business. The first step is really to minimize your attack surface. And using the IoT Blade with integration from our third-party discovery engines, you'll be able to achieve the dynamic policy that will reduce the amount of exposure those devices will have on the network. And so understanding how they function, understanding the communication mechanisms allows us at Checkpoint to apply dynamic security policies that will only allow those devices to function as they should and prevent any other activity from occurring. We also need to be able to prevent based on things like known exploits or CVEs. That is a key pillar of being able to protect the environment from known as well as unknown threats that may be affecting those areas. We also strive to quarantine infected devices. So should a rogue device find its way on your network, it'll actually be based on our demonstration today of what an attacker can do if they do breach your organization or your network. How do we deal with those devices? How do we ensure that they do not proliferate or infect other areas of the network and business? And so part of our value here is being able to provide that detailed information based on the visibility. You can't secure what you don't see, so that granular visibility is critically important. And you can see up at the top here, we have our strategic partners. If you joined us for our other session, we did a demonstration with the Armis technology. Today, I'll be covering both the Clarity and the Medigate, but I will implore you to reach out and contact us and evaluate this in your own network. Each one of these partners has a specialty, and it's worth understanding the areas of research and the areas of threat intelligence that they bring to the table, depending on your use case. It is also worth mentioning that in some instances, we work with several partners. Depending on the business, in a retail scenario, you may have warehouses as well as enterprise IoT. So again, there's no wrong answer here. The idea is to continually adjust and monitor to ensure that we're providing the highest levels of security. So now getting into the functionality, what we look at from a discovery perspective is, again, that visibility and being able to see devices. But it's more than that. It's also being able to classify devices. And you can see that we have, at a very high level, broken this out into kind of 4 key areas. But within each one of these areas, you also have discrete needs. Within the healthcare area, for instance, these are extremely critical devices supporting human life. So those are discrete requirements that may be implemented based on the visibility. And when you look at a proof of concept or a proof of a vision from Checkpoint, what we're able to provide you is that direct visibility based on your network and your system. So our discovery partners also allow us to deep dive into things like known vulnerabilities, challenges or issues, like known exploits for, say, a television, or in our example today, we'll be looking at an IP-based security camera and some of the things that can occur if you are not monitoring and enforcing the things that are that could affect it. The other portion, when we start looking at it from a security perspective, is to be able to understand things like firmware version and known challenges, because these environments aren't always the easiest to update. And that's for specific reasons. You know, you would not want to take an MRI device out of service. And in this example, we have intelligence from our medical discovery engine, Medigate, showing us that this MRI is actually vulnerable to the Blue Keep remote admin vulnerability. It's a very critical one, and it would allow an individual to take the device over and create havoc, let alone interrupting services that would be required for patients. So when we look at the risk indicators or risk exposures in these areas, they're typically fairly different than what you would see in an IT environment. Because these environments were typically not connected in years past. They were air-gapped or completely segmented. With network convergence, this has changed. We have things like network drops going into every hospital bed in large health facilities. And again, taking them out of service for firmware updates is not always an option. And so as we've brought these devices now into the larger converged network, and even into cloud-based environments in some instances from a management perspective, you can see that all of those security challenges will continue to cause issues, whether it is a password authentication issue, no built-in facility, for security. Typically, the devices are designed very efficiently to carry out specific tasks, and security and defense is not always part of that stack. As well, the concept of legacy or outdated software, or using modules that are not up to date can cause problems. As once those devices are manufactured and pushed out to the field, they're not always updatable. So within the industrial space, you also have co-managed situations, whether it is through contractors or providers of the SCADA system themselves, and they require things like remote access. They also will be very careful about which patches they allow you to apply to that system. And the reason for that is that they need to ensure that the system will function properly. In our MRI example, you would not want to update that system only to have it not function as intended. And so these are kind of the main areas or reasons that we are faced with these challenges. The way of addressing this is by automating and integrating technology that, again, can provide visibility. We're going to be getting that from our friends at the IoT discovery engines through our partnerships. But a typical deployment for any security enforcement will involve some sort of a security gateway on the network. This is typically at layer 2 or layer 3. We can also put this on a span port for a non-impacting demonstration or an evaluation of the technology. These are sensitive environments, so we may not want to block traffic at all. And then the management concept really allows you to scale these environments up because typically you're going to have more than 1 or 2 sites. You're going to scale, in most cases with us, to tens, hundreds, or with our largest deployments, thousands of sites, and a lot of activity going on. You could imagine all the devices that would be joining and leaving those networks. So a key component is that the discovery engine's information can be dynamically consumed by the security management server and actually dynamically create policies for us. And this is something that's a bit new because typically with a network security device, you would implement the policy manually based on your understanding of the network. IoT environments are simply too rapid and we need to be agile in order to meet those requirements. So let me just go ahead here and I will log into the demo environment and we will have a look at the setup that we have as well as the exploit example. So before I jump into the checkpoint side of things, what I'd like to show you is our discovery partner. In this instance, we are looking at Clarity, who is typically OT focused, but does also have IoT capabilities and other capabilities, certainly. If I look at the scope of the last few hours, last day, there is little activity. It's not until I look at a larger scope that I can start to see some of these discrete activities and some of the things that are occurring in this network segment. So if I go ahead and click on the OT or operational technology area, what I can see is that it's created quite a large list of things like PLCs or programmable logic controllers. You can see it's got the manufacturer's name here, as well as an easy way of filtering through devices. So if I want to be able to, look at really specific devices or critical levels from an audit perspective, all I have to do is select these criterion. Purdue is a common classification and compliance mechanism used in OT environments. So let's have a look at the data in that context. Now, these lists might be useful if you're processing or exporting them. Personally, I find the network graph can be a little bit more interesting. And you can see that we have, close to 430 devices here. But what it's been able to do automatically is classify the device. And you can see that based on the color. If I just right click on this object, it's immediately going to give me some information about what the device is, the manufacturer, where to find it on the network from a IP address perspective, and a whole lot of information. It's also done a risk analysis. So referring back to the cyber risk analysis that our discovery engine partners perform, this is a distribution chart showing that we have vulnerability and it's rather critical. Going deeper in, we can actually find a risk profile and a risk score. So this has taken it actually to a quotient value, has identified the fact that this is a PLC, it may be controlling something like an elevator, it may be controlling something like a shipping vessel. There's limitless application for that sort of technology. We can really see quickly which areas are going to cause problems and which areas we would need to focus on. And so for the SCADA system designer and the SCADA system operator, this detailed information is very important and very informative to be able to create policies and protections that would allow for the safe operation of the device. And the individuals who are responsible for those systems would have access to this information very, very easily and readily from within the overall system. The last area I'd like to show you here is called Insights. And this is important because we certainly have data and asset collection, and we have some analysis happening, but the insights represent a higher order of data analytics. So this engine from Clarity is also performing analytics in real time to be able to identify things like behavioral types of information or situations that you may want to prevent from occurring. And just some examples here, we can see very quickly kind of what the top 10 risky assets in the environment are. And by clicking into each one of these areas, over thousands of events, over hundreds of thousands of devices, I can very concisely see which areas I need to focus on as an operator and the information that I would be required to share with the security team in that context. So again, you have your risk score here. All of this information is available and exportable. You can see as well that when we look at things like overviews, any vulnerabilities are typically identified via CVE. So for us on the checkpoint side, that's really important because that would allow us to implement a prevention policy to block those specific challenges. We don't need to leverage all of the protections. It's a lot more efficient when we understand what's coming out of the discovery engine and we can apply it from a security context. So now I'm going to go ahead and log into the checkpoint management server. And what you see here at a high level is the security gateway that I mentioned and showed in the diagram, as well as a management server. This can manage, up to hundreds of gateways, and it scales up very, very quickly. But I'll show you very quickly the IoT controller status. So you can see this is a small lab deployment, but we still have a number of controllers to access and leverage. We can also see that we have a gateway enforcing. It's just validation that we have the right pieces in place in order to discover, classify, as well as prevent. And we'll be able to do all of those pieces today. And so you can see us over here within my objects tree. I just have to dig in and see that I've got IoT controllers. From here, I can actually go ahead and import objects. So this is an API call on the back end. It is the central security management server reaching out to the IoT discovery engine. And you can see that through both tags and filters, I can see a whole lot of different types of devices. I can filter by device tag. But tags are very important, and I just want to highlight the ability to say, identify something like a camera, and the ability for an organization to import those objects. The discovery engine is going to see them, categorize them, and database them. And just by importing these objects and hitting publish, what I'm able to do is actually make a change from a policy perspective. And you will now see this IoT layer being populated from a security policy perspective. And so a lot of you may be familiar with the network security policy. We're really not going to cover that in detail today. If you want more information, we have a lot of training and demo videos available at checkpoint.com, or just reach out to us. But it's this IoT security layer that is really based on the imported objects that we've grabbed from the controller database. And you can see that we've got an IoT building automation policy layer. So if I actually just, go ahead and close this up, make it look a little neater, you can see that there is an area for user-defined rules. This would allow me to leverage those tags and say, hey, mobile phones, even types of mobile phones, maybe my corporate standard is Android or Apple. I can make decisions based on those criterion and actually build policies out and create these layers. So I'll just use this IoT building automation layer as an example for us. Because it's done a really great job of creating a policy that allows the security camera to communicate within the network, something that we would expect. That video feed is going to have to go to a central server at some point. Now, I have not implemented this policy yet, and I've done that in order to show you the fact that if I go ahead and launch a SSH exploit against this camera, what I'm able to do is gain access to the operating system on the camera. And what that will allow me to do is attack other cameras in the infrastructure. And so it's kind of a east-west or a initial compromise that would be done by a wireless bridge or some sort of access on the network. This is actually the command shell for the camera itself. We've emulated it using a hypervisor, but if I go ahead and run this attack, you're going to see that it has succeeded according to the script. It reached a medical device located at the address listed. So Let's go ahead and have a look at the logs. I'm actually just going to hit this a few times just so that we could see it very clearly. And what we're going to see here, if I just look at the correct scope over the last hour, so this was the recent one that I just sent, this is allowed. So this is actually, SSH is a normal process in a lot of contexts. And without an explicit policy, remember, we haven't applied our policy yet, that activity is actually going to be allowed. And again, from a reporting perspective, we can roll all of the information up into a larger report. So now I'm going to go ahead and install this policy that we've created here. This is looking at things that are categorized as a high risk. Again, it's a tag. It's based on the discovery engine. And so if that discovery engine has made the assessment that the exploit or the issue is critical in nature, what it will do is automatically update the security platform. Now, the best part about this is as a security operator, you don't need to do anything but check the logs. So if new exploits or new issues come out that affect any risk level, or even something that's specific to a security camera function, again, remembering the Mirai botnet from a number of years ago, that exploit affected a number of different systems, either of those activities are going to be blocked automatically. And you can see as well, I have a cleanup rule that makes account for anything that I have not put in the policy explicitly. So essentially anything that's not explicitly allowed is going to be denied. So now we have that policy deployed out to our site. We may have deployed out to 100 devices. Let's go ahead back to the console here. We're on the attack console, and we're going to run this attack again. Now you can see that it's timing out. It's not functioning as quickly as it did in the past. And what I can do here is go ahead and show you from a logging perspective. I'll just hit refresh on these logs again. You're now able to see that I was able to block this attack. And so had I simply imported the objects and applied the pre-prescribed automated IoT policy from the centralized management server, all of that would have been prevented immediately. But as a lab example, we're actually able to step through the different points of the exploit. And now we can actually see this in our logging and reporting. So you do remember the Clarity dashboard. It was providing a lot of rich information. We can see that information as well in context of a network and host level security. And so you can see that there are alerts, even based on past activity, that we can see over time. And so it's really easy as that. You know, all you need to do is have the integration with the IoT discovery engine. From there, you are doing automatic identification and classification. Don't forget about the security analysis on those devices. And that is what allows you to automatically create distinct policies and profiles for IoT-based devices. And that's based on their attribute. So I want to thank you very much for your time. I'd invite you to reach out to us at Checkpoint, and we can help you look at this technology within your own environment and evaluate and implement to protect your organization.